Okay, so again, unfortunately, the software that I wanted to have installed on my computer in my classroom is not quite ready. So I'm going to have to do it like this for today. Hopefully by Monday it'll be installed and ready to go, and we won't have to do this confusion with the recording. However, this will be uploaded to YouTube, so everybody can watch it, enjoy it. And so you might be asking, how do I ask questions? Well, you can, of course, always email me your questions and just let me know what you need clarification on or what you need help with. You can also put your questions down in the comments section of the YouTube video. That works too. I also check those. But the email is probably the best way to get a hold of me and get those questions answered in a timely manner. So let's go ahead and get started. So, of course, this is Math 0342, Introduction to Statistics. And the big question I'm sure is on many people's minds is, why am I in a statistics class? That sounds like a upper level math class, something that I'm maybe not supposed to be in. No, I assure you, you are in the right place. Many people have the stigma that statistics is something that is complicated and very difficult to master. And while, yeah, that can be true for some of the upper level things, I feel like the statistics that we're going to be going through is not only going to be pretty simple, but vital to everyday life. Really, what I expect you to learn from this course is statistics literacy. So, learning how to understand statistics, especially when people quote it to you, because many people tend to use statistics to try and lie. They will use statistics in a way that benefits them, benefits their causes, and will mislead the common man. Okay? So I have a few examples of this that I can think of. One is an example that says the more firemen that arrive to a house that's on fire, the worse damage there will be to the house. Now, this is absolutely true. Of course, the more firemen that arrive to a house, the worse the damage is going to be. However, there's not really correlation there between the damage and the firemen. What's really going on there is that you need more firemen for a bigger fire, and the bigger fire is what is going to cause the damage. So while there is something going on, more firemen, more damage, the statistics aren't really being quoted correctly there. They're being presented in a way that is misleading. Another example, and this one's a very famous example, the more ice cream that is sold, the higher the murder rates are in a particular area. Again, that is absolutely true. In fact, that's something that I was told in my psychology class when I was a college student. Again, the more ice cream that is sold, the more murders there are. So, is that true? Yeah, it is true. You can look at numbers for that. However, it's not really correlation. What's happening with that one is as temperature rises, as the weather gets hotter, as the climate gets hotter, of course, more people are going to buy ice cream. It's an easier way to cool down. However, people are also going to commit more violent acts as the temperature increases because it's harder for humans to control their emotions when the temperature is much higher above what they're more used to. So, again, these are two examples of perfectly sound statistics, but quoted in a way that is very misleading. So you can make statistics say what you want them to, even if that's not really what's going on behind the scenes. So let's get into some basics. First of all, something that I'm sure Miss Lamar has already gone over is the difference between a population and a sample. So let's go ahead and put population in here. Again, I'm sure Miss Lamar has already gone over this. However, I want to go over it again just to reinforce the idea. Population is where everything is represented in a particular demographic. So if you have a group, everybody in that group is being represented with your data. So in a population, the entire group is represented. Okay? So, an example of this, and this is the example that I was giving in class today, is the height of all NBA players. Okay, so we are looking at the height of them, and we're looking at all NBA players. So everybody in that group is being represented. And this is actually a very easy population to get a hold of. You know, obviously the NBA has statistics on everybody, and they can get everyone, literally everyone, that is playing for the NBA. Now, kind of opposed to that is a sample. So if a population is everybody, then you could assume that a sample is just a part of the group. So what we can say here is that some of the group is represented. Whoops. Now, is that fair? Is it a good idea to use a sample? Well, yeah, it actually is okay. A sample can be an easy way that you can get an overall idea of what the population would be. So, an example of this one would be, again, like I was using in class today. The people of Minnesota were polled. Okay, so imagine that you want to learn some stuff about the people of Minnesota, maybe what their favorite drink is. Okay, and so you go out and you survey people in Minnesota and you get data from them. Now, are you going to be able to survey every single person in all of Minnesota? No. And in fact, you're probably not even going to be able to get everybody in every city. Most likely, if you were doing this survey, you would go to major cities and major areas in those cities, well trafficked areas, and you're going to be getting those people's responses. And so, yeah, you're going to get an idea of the general most liked drink in Minnesota. However, you're not going to get everybody's opinion. You're not going to get every single point of data. So yeah, you're going to get an idea, but you're not going to get the entire population. Now, it's important to note that with these samples, some biases can come in, and you need to really be aware of that. First of all, when taking a sample, make sure that the number of data points you have in that sample is as many as you possibly can get. And so instead of just interviewing 5 people, try to go for something like 500. 5 people do not represent the entire population of Minnesota. 500 is closer, but more is always better. Okay? Also, think about what we just said with where we were going to do those surveys. We're not going to every city in Minnesota, we're going to the largest ones. So are we getting everybody's idea of what the best drink is? No, we're getting the idea of the people in the largest cities. So there's a little bit of bias there. Maybe people in the more rural areas of Minnesota don't drink the same thing as the people in the large cities. Also, we said that we're going to go to the most trafficked areas, and, well, maybe those places are shopping centers, things like that, places where people have a little bit more money. and so can afford a different kind of drink than other people that might not be in those heavily trafficked areas. That's another introduction of bias. So we have to keep those in consideration when we're looking at samples. It's always a good idea to keep those in consideration, whether it be a sample or a population even, because just the way that you collect the data can introduce bias. Think about the questions that you're asking. How are you asking those questions? What are the possible answers? What are you allowing in your data? So keep those in mind. Always have as big of a data sample as you can, but also think about the biases that you're introducing to this data. Okay, but let's move on. Some ways that we can sort of analyze, analyze our data, kind of at a glance, is with mean, median, mode, and range. So these are 4 tools that we can use, and they are parts of other calculations that we can use for more complex statistical analysis. However, we're going to start out with these 4 because, again, they give you a sort of broad idea of what the data is doing overall. So let's start with mean. So you've probably heard of mean before. You probably use a different name for it mostly, and that is the average. Okay, so the average is going to give you a general idea of what your overall data is going to look like. Basically, you can think of average as being if we were to randomly select a single point of data from our entire set and just look at the number and then compare it to our average, it's very likely that our average is going to be that point or very close to it. It's going to be the same number or a close number. It's going to be similar to it. So again, average kind of lets you know what most of the data looks like. Is it going to be representative of all the data? No. After all, the average height is somewhere around 5 feet, and there are people who are not 5 feet. They don't fit that average. But if you took one person out of everybody in the US and looked at their height, it would probably be somewhere around 5 feet. So again, an average gives you a general idea of what your data is going to look like. Now, another way to look at it is that your average should be somewhere around the middle of your data. Most of your data points are going to sort of group around the middle, and again, that's because overall, there's going to be, most people are like the example I said, 5 feet. So there's a lot of people there at 5 feet in the middle. Then you have some people who are 4 feet, some people who are 6, 7 feet, and it tapers off towards those lower and higher ends. So most people are going to be 5 feet. That's that middle data. It's going to have the most points in it. And again, our average is going to be towards that middle part where most points are. It's not always going to be right on it, though. And we'll talk about that more as we go on through the semester. Now, to calculate average, you're probably familiar with this already. But what we do is we take all of our data points and add them. And of course, what we get when we add a bunch of numbers together is called a sum. Then, once we have that sum, we will divide it by the number of data points we have. Okay, so again, we take all of the data points that we have, add them together to get a sum. And then we divide that sum by the number of data points we have in our set. Now, just to note, the number of data points we have in our set is called n. So if you see something like a news article or a headline that's quoting a statistic, they will often put at the end of that n equals some number. And so their n is the number of data points they have. And like I said, the more data points you have, the better. Okay? So let's give this a little bit of practice. Let's say that I have a set of data, 1, 3, 3. I'll put spaces in there so it's easier to see. 4, whoops, 4, and 9. Okay? So if we were to, sum this up and get our average, this would be, let's see, 1 plus 3, that's going to be 7, and then 7 plus 4 is 11, and then 11 plus 9, that's going to give us 20. Okay, so again, we add all those numbers up, we get 20. Okay, so now we need to take this number and divide it by the number of data points that we have. So how many data points do we have? Let's see, 1, 2, 3, 4, 5. We have 5 data points. So we're going to go ahead and divide our sum, which is 20, by the number that we have, our n, which is 5. Okay, so let's see, what's 20 divided by 5? 20 divided by 5, well, that's 4. So that means that our mean is 4. Again, that's our average. If we were to take a look at any one of the numbers in here, just at random, it would probably be around 4. And let's see if that's correct. So if I pick one at random, this one. Yeah, 3 is pretty close to 4. Again, 3 is pretty close to 4. 4 is 4. 9 is not very close to 4, but it is one of our outliers. It's one of those things that's way far away from the middle. 1, again, is not exactly 4. It's not exactly close to it either. It's an outlier. It's kind of off from the center. But these 3 right here that are in the center of our data, they do seem to be kind of towards our average. And so that's what we would expect to see with a typical mean. Okay, so let's go on to median. So, median, kind of like average. Average, again, is what we can expect to see towards the middle. Median is the middle. It's what the physical middle of our data is. Okay, so it is the middle number. All you do is you just look at your data and find what number lies in the exact center. Now, before you do that, you need to order your data. So, first things first. Whoops. So make sure that you order your data from least to greatest. The reason I say that is because if you don't have it in order, I mean, anything could be your median. You could put this data in all sorts of different orders and you'd come up with a different median every time. So make sure that when you have your data and you want to find your median, you order it from least to greatest so that you can actually find that middle number, the one that lies directly in the center. Okay? Now, sometimes you aren't going to have one number in the center. when you look at your data at least. So again, let me give us some numbers here. Something like, I'll make it simple, 1, 2, 3, and 4. Okay, so if we look at this here, and we wanted to find the middle number, well, right in the middle we have 2 and 3. That's not a middle though. We can't have two numbers be our median. We have to take the number that is directly between 2 and 3. Okay, so what is directly between 2 and 3? Well, that would be 2.5. Now, the easiest way to find this is to take the two middle numbers and find their average. Like I said before, that mean is towards the middle. Now, when we just have two numbers like we do here, where we're looking for the number between these two, that average is always going to give you the thing specifically in the middle of both of them. So in this example, we have 2 plus 3, which of course equals 5. Okay. And then we divide by the number that is in the middle. I'm sorry, by the number that we have of data points, which in this case again is 2. So if we divide 5 by 2, we get 2.5. So that's how you're going to want to find your median if you have two numbers in the middle there instead of just one. All right, how about mode? Okay, so mode's a little bit different. Mode is the number that occurs the most. Okay, so if you have a set of data, of course, sometimes you're going to have numbers that repeat, you know. Say you go to a first grade class and you ask each student, how many pets do you have at home? Well, a lot of them are going to say 1 or 2. And so that mode is going to be the one that occurs the most. So let's say it's 2. 2 would be your mode. In fact, let's take a look at some examples. So again, going back to the pet example, if we pull them and we have students that say, I have 1 pet, I also have 1 pet, I also have 1 pet, well, I have 2 pets, I have 2 pets, I also have 2 pets, I also have 2 pets, and then there's one that says, well, I have 5 pets, I'm cool, you know. Well, our mode here is, again, the number that occurs the most. 1 and 2 occur more than once, but 2 is the one that occurs the absolute most. It occurs more than 1 and it occurs more than 5. And that's important because since there's so many 2's, the average is going to actually tend toward that number. Okay? So again, the mode here, being that it is the one that occurs the most, is 2. If we look at another example, let's say that I have the same thing, but this time when I pull a different class, I get 1, 1, 1, 2, 2, 2, and then maybe like 3. So now I have 1 and 2 both occurring 3 times. They're both happening the same amount of times, and they're both happening the most amount of times. Okay, so because both of these equal each other out at being occurring the most, we actually have two modes. So our mode for this set of data would be 1 and 2. And you could have 3 modes, you could have 4 modes. You can have any number of modes. You can have many, many numbers. Okay, so what about an example like this? 1, 2, 3, 4, 5. Well, does any number occur more than any other number? The answer is no. So, because no number occurs more than any other number, that means that our mode is no mode. There is no mode. Nothing's actually skewing that because nothing is occurring more often than anything else. So you can have no mode, you can have 1 mode, you can have 2 mode, you can have any number of modes, like I said. But you don't necessarily have to have a mode either. Okay, last one. Range. So, range is also a little bit different. It's a measure of the variation between our data points. Or one way that I like to put it is, how wide is your data? Okay, so looking back at some of our previous examples, there's a lot of variation here, not as much as there is here. We go from 1 all the way up to 5. This one just goes up from 1 to 3. So how do we measure this? So this one's very easy. All we do to find the range is subtract the smallest number from the biggest number. So if I use this as an example, 2, 2, 4, 7. Again, we would subtract uh, 7 and 2. We subtract the smallest one from the largest one. So 7 minus 2. Oops. And that gives us a range of 5. Okay, so again, that's a measure of the variation in our data. Or, like I like to say it, how wide the data is. If you have a very small range, maybe you only have 1s and 2s in your data, then that means you have a range of 1. That's a very thin range. There's not a whole lot of variation in your data. On the other hand, if you had something like everything from 1 to 500, then of course 500 minus 1 is 499. That means you have a very wide range of data. There's a lot of variation there. And that doesn't mean that you have a whole lot of data points either. You could say that our 3 data points are 1, 3, and 500. And your range would still be 499. It's still a very wide range. You could have 500 data points, but like I said, only 1s and 2s. And so 1 being the smallest number, 2 being the highest number, you only have a range of 2. So it doesn't matter the size of your data, how many data points you have. It's really how far the smallest one is from the biggest one. And again, that's variation. Okay, so let's actually calculate some of these things in some examples. So I've got a set of data here that I was using in class today. 5, 7, 2, 6, 2, 3, 9. Okay, and we want to find the median, mode, range, and mean. Well, the first thing we need to do before we start doing any of that kind of stuff is order our data. So we need to make this go from least to greatest. So we have 2, 2, 3, 5, 6, 7, 9. So all of our data is represented. It's just now from least to greatest. So that's going to allow us to find our median, which if we look at our data and find the middle here, that's right at 5. So our median is 5. Oops. Mode. So again, that means what number occurs the most. Well, again, if we look at our data, everything looks like it occurs once except for 2. 2 occurs twice, so it's occurring the most. Our mode is 2. Range. So how varied is this data? Again, what we do is we take our smallest number and subtract it from our largest number. So 9 minus 2, that's going to give us a range of 7. And finally, our mean. So we need to add everything up and then divide by the number of data points that we have. So if we add this, let's see, 2 plus 2 plus 3 plus 5 plus 6 plus 7 plus 9, that's going to give us a sum of 34. And then we need to divide it by the number of points we have. 1, 2, 3, 4, 5, 6, 7 points. So 34 divided by 7, that's going to give us 4.86. I have to round a little bit there, and it's always a good idea to round to at least 2 decimal places. Okay, so let's kind of look at our data in comparison with our metrics here. So median, 5, right there smack dab in the middle. We know that the mean should be kind of close to, if not the same as, the middle. So is this close to our middle number, which is 5? Yeah, it is decently close. 4.86 is almost 5. It is being drugged down a little bit, probably because our mode of 2 here, but it is very close to 5. And this is what you can expect to see with our typical data. If it's normally distributed, it's going to be something like this. Our mean is going to be very close to our median, if not the same. Okay, so again, this is what you should expect from data. So let's now see some things that are not really what you would typically expect. How about a data set like this? All ones. Well, the good news is we don't need to order it. It's already in order. Okay. So median. Well, our middle number is definitely 1. Mode. Do any of these numbers occur more than the others? No. So you could say that there's no mode. Range. Well, range is largest minus smallest, so there's no variation here. 1 minus 1 is 0. Again, there's no variation, so 0. So what does that mean our mean is? Well, as you could probably guess, 1. We add up all those 1s, we divide by the number, we get 1. So, how representative of the data is this? Well, our median is 1, and is our mean pretty close to that? Yeah, it's smack dab on the median. And so could we say that this average is representative of this data? Yeah. Again, the average is that if we randomly select one of these data points from this set of data, how likely is it that it's going to be on the mean or close to it? And in this case, it's 100%. It's always going to be that. So yeah, we can say that this average is representative of the data. How about something a little bit different? Okay, 5 zeros and a 6. Same things. Median. Mode. Range. And mean. Okay, median. Well, if we look for a middle number here, we end up with 0. Okay. How about mode? Well, there's definitely one that occurs more than in the others, and that is 0. Range. Well, smallest, subtract it from the biggest, that's 0 from 6 is 6. And mean. Okay, so take the average of this. 1, 2, 3, 4, 5, 6. Whoops. There we go. Now it looks correct. So again, 1, 2, 3, 4, 5, 6. So 0 plus 0 plus 0 plus 0 plus 0 plus 6 is 6. Divide by the number of data points we have, which is 6. 6 divided by 6 is 1. So we again get a mean of 1. Now, the question we need to ask ourselves again is, does this represent the data well? Okay, so think about it like this. Think about each of these sets of data as being the amount of apples that a person owns. So each data point is a person, and the number is the amount of apples they have. So up here in this data, every single one of these people has 1 apple. So on average, they have 1. Does that make sense? Yeah, it does make sense that on average, everybody has 1. Down here, we have no apples, no apples, no apples, no apples, no apples. This person has 6 of them. So the average says that on average, everybody has 1. I don't think so. We can definitely see that most people don't even have an apple, and only one guy has any. In fact, he has 6 of them. Okay? So again, be careful with data. There's a lot of people out there who will tell you something like, oh, well, on average, everybody here has 1 apple. No, that's not exactly right. You have to really look at the data and understand what's really going on here. Okay, so I think that will do it for today. Again, if you have any questions, you can either leave them in the YouTube comments below, or you can just email me. Hopefully, we will be having our live lectures starting on Monday. Again, I will email you in advance and let you know what we're going to be doing for Monday. And if we unfortunately will not be able to do that, then we're going to go back to this, and I'll just record lectures here at home and upload them to YouTube for you. All right, but that is it for today. I hope you have a good weekend, and I will hopefully see you on Monday.